Hi, we are here today to do problem solving for assignment 2. So let's get started with the first one. From the first question, the accompanying figure shows two situations, an electric field vector E and an induced magnetic field line B. Which statement is correct? So yeah, the solution is easy. What we have to use in this question is the curl right-hand rule. This thing, our thumb will be the current and the rest are the magnetic field. And you can see that the first figure, the first one, the current is going in anti-clockwise, which means that the current will be upward, like this. And also with the figure B, the magnetic field is going clockwise, which means that the current is going downward. What we do next? You can see that the current is quite opposite with the electric field on the fourth figure, right? So what happened? It means that the electric field is decreasing. Why? Because, yeah, if the initial one is going downward like this, then if it is decreasing, the final one will be smaller, which means that the delta E will going upward. And this thing will lead to the upward of current. And yeah, it's also applied with the figure B. If the initial one is like this, so the final will be like this, and then delta E will be downward, and it makes the current downward too. So yeah, the answer is second choice. Both A and B have a decreasing electric field.
Hello, today we will talk about the third question of assignment 2. For the question is the voltage across a parallel plate capacitor with area A and the separation D varies with tan t as V equal AT squared, where A is constant. Find the displacement current between the plates. Okay, so first of all, we know that the displacement current formula is ID equal to epsilon 0, epsilon naught, d flux by dt. And then we also know that flux is equal to E multiplied with A. So we insert it inside this equation. But A is not vary with time, it is a constant value, so we can move it out of d by dt. So it will be epsilon naught A dE by dt. And then we will change it again by we know that E is equal to V divided by D. And we also insert it inside this equation because we know that D isn't vary with time while V is vary with time. So we write it in this form. So the next step is we need to find dV by dt. So we will use this equation to find it. So dV by dt is the differential of V equal to a t squared. And the result is 2at. And then we will insert inside this equation, which is epsilon naught a multiplied with 2at and divide with d. So we need to recheck again that are there any variable that we use and it more than the question give it to us. So in this question, they give a, d, t, and a which is the acceleration. Okay, so we will see in our answer that we also have the epsilon naught that more than the variable in our question. However, epsilon naught is a constant value, so it is okay to answer it. And this is our answer. Thank you to listen about this solution. Thank you again.
Hello, this is question number 9. It is about a parallel plate capacitor which has an area of 0.25 square meter. I'll write it here. And the separation of 0.01 meter. It prompts us to find the angular frequency, or omega, to give us the maximum displacement current of 1 ampere. And it also gives us the function for voltage over time, which is this one, and also V0 is equal 100 volt. So what we should start is to start at the displacement current function, electric flux over time. And since we don't know about electric flux, so we can transform it into other variables. So we know that electric flux is equal to electric field multiplied by the area. So we substitute it into this equation. And since the area is a constant, we pull it out of the differentiation. However, we still don't know the electric field, so we need to find another value to plug it in. And since we know that electric field is equal to voltage divided by the separation, so we know that separation is also a constant, so we pull it out of the differentiation. And we'll get this equation of displacement current. Alright, here again. Okay, so now what we need to do is to differentiate the v function, which is dv by dt. So we have this function already, so let's go ahead and differentiate it. So v0 is a constant, so we pull it out. And sine omega t can be differentiated into cos omega t times omega. So that's the differentiation, and we get dv by dt. So what we have to do left is to plug this value in. And the last thing we need to do is to substitute the values. We have the areas of 0.25 square meters and V0 at 100 volt. And now they need us to find the maximum displacement current. So we know that the function cos can never be more than 1, and the maximum value of function cos is 1. So we just substitute this cosine function with 1. So it will give us the maximum value of dv by dt, which will in turn give us the maximum displacement current. And we will let this angular frequency here because it's the thing that the question prompts us to find. And when we summarize all the information, we will get this equation, the separation value is 0.01, and dV by dt is 100 volts times omega. And we know that the displacement current is 1 ampere. We can plug it in. And what's left is solving the equation for omega. Okay, so I'm back from calculation with the calculator, and we know that the omega value or angular velocity is 45 million or 4.52 times 10 to the power of 7 radian per second. Thank you.
Okay, and let's do another question. The 11th questions. A parallel plate capacitor with circular plates of radius r is being discharged. The displacement current through a central circular area parallel to the plate and with radius r over 2 is 2 ampere. What is the discharging current? So the question is asked about what is the discharging current. Discharging current is mean that the current before it discharged, like it is going to be discharged. So what is that? Like it is look like the after one. So the equation that we're going to use in this question is the displacement current equal to epsilon the electric flux by dt, right? And we know that electric flux equal to electric field multiplied by area. So we know that the area is constant, right? So we put the things out and we get the rate of electric field. And the area in this question is the circular plate, right? So it is a pi radius squared. Okay. So what we know here is the after one, the radius r over 2 and the current that is 2. So we put things like this. ID. What we know is this parent current is 2. Just like this, stay like this. Pi r over 2 square and leave the rate like here. Okay. And to see more clearly, we put the variable to the left and the number to the right. And this thing, 2 square is 4. Move to another side, so it's 4 multiplied by 2 equal to 8. Yeah. And then before, also the same equation. And what we want to know is this thing. The discharging current is this one. So we put the variable h mat as we know. This one is radius r. Oh my god, do you see what? This thing and this thing. It is exactly the same, right? So then it is equal to 8 ampere. So it is also ampere. Easy, right? Nothing much, just you have to compare and know the variable. So the answers of this question is 8 ampere. Thank you for watching our assignments. That's all. Thank you, Aki.